we see two varied perspectives of linear combinations and coefficient matrix and variable column. So this is very important. See this. So we have two input equations, 2x minus y equal to 0 and minus x plus 2y equal to 3. Okay, so we want to solve this using this first perspective and the second perspective. In the first perspective, what do? We create the coefficient matrix and we have the variable matrix x and y, and then we equate with the two constants 0 and 3. We have already seen this thing, okay? So if you remember the matrix multiplication, so this row and this column, if you multiply, you get this equation, and similarly this row and this column you multiply, you get the second equation, and then you equate them with the constants, then you actually get the whole thing. Now you see from this, if we are trying to solve it, we will try to find out from equation 1, let's say, so if x equal to 0, what will be the value of y? Y will be equal to 0, okay? And then again from equation 1, let's say try another point. So multiple points can solve this equation. So let's see another point. What if x equal to 1? If x equal to 1, y is equal to 2. Okay, so these are the 2 points we got from this equation. And using these 2 points, we can draw a line. Let's see this. It's a two-dimensional coordinate plane. And in this plane, if two lines are not parallel to each other, they will intersect, okay, and then give one solution. So you see this, the first point, x equal to 0, y equal to 0 for equation 1, I plotted here x equal to 0, y equal to 0, and the second point is x equal to 1, y equal to 2. So this is this point where x equal to 1 and y equal to 2. So, okay, so through these 2 points, I draw this line which is representing the equation 1. As you know, it's a linear equation, so it will be a line. And then so you can have any values, any points on this line, and that will satisfy the equation 1. We can choose like x equal to 3 and then the corresponding value of y. That will be a solution for that equation, and similarly, okay? So these are just 2 points. Now see the exactly same way for equation 2 also, we find 2 points. One is, let's say x equal to minus 1, then it will be minus plus, and then 2y equal to 2, and then y equal to 1. So x equal to minus 1, y equal to 1, and similarly x equal to, if we say y equal to 0, then we'll get x equal to minus 3. Now let's see these 2 points in this green line, and you will find out that x equal to minus 3, y equal to 0 is this point on the x-axis because y's value is 0, and the other point x equal to minus 1 and y equal to 1 is this point. Now once again we got 2 points, we can draw a line through it, and we find out that these 2 lines intersect at this particular point, and this point is again the point 1 and 2. Okay, so if you put this 1 in this equation, the value of x1, then you will see from either of this equation you will get the value of y2. That means this is a solution. As one more time, as I said, that if two lines are not parallel to each other in a two-dimensional coordinate plane, then they will intersect at a particular point. And what is that point means? Intersect means in that that particular point is common to both the lines. That means both the lines have that point. Okay, so now but this same thing cannot be said true for the 3D space. In a 3D space, 3 lines can be perfectly not parallel to each other, but still not intersect. Okay, conceptualizing 3D space is not easy. So let's see one thing. As I said, in this line, any point will be satisfying in any of this equation for a particular, like red line will satisfy equation 1, any point on the red line, any point on the green line will satisfy equation 2. But same thing cannot be said for a 3-dimensional space. But for 3-dimensional space, there are x, y, z, 3 different coordinates. Okay, so if x equal to 0, there is an equation called x equal to 0, then that actually means in a 2D plane the y-axis. X equal to 0 means the y-axis, okay, and y equal to 0 means the x-axis. But in a 3-dimensional plane, x equal to 0 represent the yz plane. Says that x-axis have no value, but yz has. So in that plane, any point will be satisfying that equation. And similarly, if y equal to 0, that means x and z plane, and if z equal to 0, that means it's a xy plane. Okay, so this is a 3-dimensional case. Now come back to the linear combination perspective, which is kind of in contrast to the previous perspective. And you see what we did. We have the variables x, y outside, and then we have the corresponding coefficients of x and y. and then we create a linear combination of them. Okay, x times this column matrix as a vector, and then y times this column matrix equal to this. So if you remember that the vector equations, what we are trying to find, we are trying to find some values of x and y so that the combination of these two vectors becomes this vector. Okay, if you remember that ax plus ax equal to b form. So no, this is this form. Okay, the vector equation form where x times a, which is a vector, plus y times b equal to b. So is there any value of x and y such that this combination is satisfied? So that's the yes no type of question. Let's see in a graphical form how you can represent this. So we already know that yes, if we have x's value y and y's value 2, then this equation will be satisfied. Okay, so let's see now graphically with a vector addition concept how it works. Okay, so now you see, as I said, this is a vector. Okay, a is a vector, 2 minus 1. So what is the main meaning of 2 minus 1? We have already seen 2 minus 1 is value of x is 2, y is minus 1. So this red line shows this vector a, okay, where the value of x is 2 and the value of y is minus 1. This is the red line. And then we have the other vector, which is value, the value of x is minus 1 and value of y is 2. This is the vector b. You see minus 1 and 2. This, the green line, is the vector b. Okay, now you see one important thing, which is that what we are trying to do, we are trying to add a linear combination, okay, creating a linear combination. And we said, let's say x's value is 1 and y's value is 2. So this particular vector will multiply with a scalar. What happens multiply with a scalar? The direction remains same, but the magnitude doubles. Okay, so if the magnitude doubles, the magnitude will become 2 times minus 1 and 2 is minus 2 and 4. Okay, so now I draw another vector. If vector addition, if you remember from tip to tail match. Okay, so so this 2b, this vector, the black line, and we merge it with the, we match this tail with the tip of the vector a. And then if we draw this 2 times, minus 1 and 2 will be minus 2 and 4. Okay, minus 2 and 4. And then if from this point, which is 2 minus 1, the tip of a, if we go minus 2 and 4, minus 2, this y-axis, and then 4 from this position. So that becomes actually this point at 3, the black line. So this is basically nothing but the 0, 3 point. Okay, 0, 3. Now you see 0, 3 is the solution we were looking for. That means we find out the linear combination of these two vectors created the third vector, which is b. Okay, and graphically we have shown that.